scatter diagram and correlation. This is short and easy one as compared to the very last chapter we did. So basically these are graphs. Correlation, as we would be comparing two things on x-axis and y-axis by variate data, comparing two data as old and new. Scatter diagram would be having points which are exactly not on the straight line. Dependent variable is always on x-axis. Positive correlation means directly proportional. One is increasing, the other is increasing. This is positive correlation. Whatever the graph will be telling us, that will be trend, if it is increasing, constant, or decreasing.
Sorry, so positive correlation is always increasing, right?
Yet directly proportional, yes, increasing or maybe decreasing, but both increasing or both decreasing.
Okay.
For example, if I say that this is 2000 and the sales were, let's say, this much, and then I say this is 2010 and the sale is this. So basically, let me just not use time. So let's say weight of a puppy and food quantity. So high weight means he's consuming more food, less weight. So if the weight is decreasing, he's consuming less food. So basically both are decreasing. The graph is this way. If it's losing weight, and if it's gaining weight, it's the other way around. Both are increasing. So correlation is both increasing or both decreasing. This would be positive, and negative is one increasing, the other is decreasing.
Okay.
Then no correlation would be basically a straight line, or we'll have very much scatter, like we won't be able to, let's say this is the data. So we cannot say either it is decreasing or it is increasing. So no correlation. The line of
What do
best
you
fit,
mean by the data is all over the graph?
random data. For
So it
example,
can't be, so it can't be graphed?
no, that can always be graphed, but we won't be able to comment on it.
Because it'll be too random.
Too random. We would say that it is not a reliable data.
Okay.
For example, students from class 1, how many marks did they get? And let's say we have few students who got these much marks. Some got 10, some got 20, some got 30, and then class 2 and so on. So basically we cannot correlate anything. Compared to this data, if this is the trend, I can still say that somehow it is a positive trend.
Because it doesn't follow one straight data.
Yeah, for example, we are compiling data from a gym, and I say this is the age and this is the weight. So let's say we may have someone whose age is 60 years, and he may weigh like 50 or 60 or 70 or 80. So we may have multiple values for this type of data. So I cannot comment that with increasing age the weight is increasing, or with increasing age the weight is decreasing.
So if there's multiple forms of data, that means there will be no correlation.
Yes.
Okay.
But for us, that would be very easy because we'll be having data to comment. We'll be having graph to comment on. Like we don't have to guess what would be the relation between these two.
It'll already be done for us.
Yeah.
Okay.
For example, you would know when we buy something in large numbers, the price is actually lower per unit. Do you agree? Like
Lower
if
for
per unit. For example, we are buying like 10 cups, 10 plastic cups versus We are buying 110 cup. So maybe when we are buying 10 cup, the shopkeeper is charging us $1 per cup. And when we are buying 110, maybe he's charging us 0.85 per cup.
Oh yeah.
So see, when we increase the number, this is decreasing.
Yeah.
So it is negative correlation. On the other hand, when the consumption increases, that means the demand is increasing, the price also increases. For example, fuel, food, etc.
Yes. Okay.
This was for sake of discussion. For exam point of view, that would be very clear. There is no ambiguity. We just have the data and we have to analyze it. And then line of best fit and extrapolation. What is extrapolation? Extrapolation is this. For example, we have data till 80, not more than that. And suppose these are the two extremes, and I draw this line. Now you have this graph, but the examiner is asking what would you expect at 100. So we are going out of this line means extrapolation. The line still has same gradient. We know the x, we can find the y. And when we work between these 2 points, this is known as interpolation. Outside the points is known as extrapolation.
So
That
intra
is
is inner inside the line and extra is outside the line.
yes, yes.
Okay.
Okay. Recap. With a glance at this picture, you would have recalled what it looked like. You should already be familiar with the following scatter diagram concepts. Scatter diagram. So we are having all the random points and we're just plotting them on the graph. Let's say the age is 1 and height is 0.6, which corresponds to this point. And then age is 7 and height corresponds to 1.1. Third age is 3, height is 0.8. And age is 2 and height is 0.7. So we have this data, a random data, and we're just plotting it. Once done, now I was not able to interpret it from this point because these are in random order 1, 7, 3, 2, increasing, decreasing. But once I have this graph, I can say that this is sort of a positive trend. As the age is increasing, height is increasing. Clear?
Yes. Yes.
So this is the limit which we would be facing, which we have to solve. So see, positive, both are increasing. Negative, one is increasing, the other is decreasing, and no correlation. I cannot actually say that this is my line of best fit or this. What actually line of best fit is? We draw one line which passes through or close to maximum points.
To all of them, right?
Maybe maybe 0 points. See, 1, 2, 3, 4, 5 points. I drew 5 points. Now I'm going to draw the line of best fit. So it passes between all of these and never touches one. Compared to if I draw this blue line passing through these three dots and I draw this orange line passing through the points below. So if I draw this orange line, we are ignoring these three.
And
And
if
when I
you're above one, you're ignoring the bottom ones.
yes, in the
So,
blue line, we are ignoring these two. But the green one shows the average of complete data. So that's line of best fit.
so it has to never touch the lines, but go through like the middle.
Yes, won't matter even if it touches zero. See this first one again, positive. So I'm drawing this line. Please avoid the shaking of hand. This. See, it passes through some, but it actually represents the average of all.
Is this like results a bit exaggerated because they're so close to each other? So it'd be pretty hard going through like in between all of them without curving the line a lot.
Yeah, that's just an hypothetical example. It
Yeah.
would be much better and lesser points
Okay.
which you will face. Yeah. Introduction to bivariate data. So far, you have seen how to summarize data and draw conclusion based on your calculations. In all cases, the data has been a collection of single measurement or observation. Now think about the following problem. An ice cream parlor sells its goods throughout the year, and manager needs to look into how sales change as the daily temperature rises or falls. He chooses 10 days at random, records the temperature, and records the total takings at the tills. The results are in the table. So days are increasing ABCD, temperature is changing, and total sales. Just before drawing the graph, let's try to do so. Temperature is 4 and sales are 123. Temperature is 18, sales are more. More temperature, more sales. And 32, more temperature, more sales. Minus 3, less temperature, less sale. So I can see that this would be somehow a positive correlation.
Yeah,
Now,
there's one result that doesn't really fit into it. J 31.
maybe that would fit. See, just 32 and 31. They're close and the sales are also close.
Okay, so if it's like very off, then it'd be like something like an anonymous result.
Yes.
Okay.
That too would like that would be if I just put a point over here. We'll ignore this point and then draw a line of best fit.
Okay.
So this is the data. Sorry, this is the data and this is the scatter plot. X-axis is temperature, y-axis is sales. What do you think? Temperature is independent or sales?
I think temperature is independent.
Temperature, right? So temperature changes and the sales are affected. So this is the scatter diagram. And with a glance, we can say that yes, it is a positive correlation. And see the trend seems to be increasing trend, increasing temperature shows increasing sales. Okay, now let's see. Had the points been placed from top left to bottom right, obviously, if these points were in this way, we would call it
Negative.
negative correlation. Some examples to clarify. First one, strong positive. Second one, weak positive. Third one, no correlation. Understand the difference. Strong positive, if I draw a line, they will actually be close to line, all of them. So weak positive, I'm drawing a line, but they are further away from the line, although it shows an increasing trend. And third one is obvious,
No.
no correlation. And again, this second one is strong negative because that all of them are close to the line. And this is weak negative. And we call this line of best fit. Now see, this is the same graph as this was. If I would have chosen these points, I'm ignoring all of these because line has to be straight. We'll be using pencil and ruler only. So see, if I draw that line of best fit, I'm ignoring these points. And if I choose something else other than this, I think that's a better line, or this. So roughly, there are 1, 2, 3, 4, 5 points above the line and 3 points below the line. Okay. Once we've done this, we've plotted the points and drawn the line. Now we are going back to basics again. The examiner would see, for example, if I say how many sales are there when temperature is 10. So we will not answer this. We will follow this line and I tell that this is the sale. So 100 by 5 is 20. 1, 2, 3, 4, 5, 6. This is 260. Any confusion in this 260?
Yes. Why? Because isn't the original data the blue one?
Okay. If I ask you at 15 degrees, what would you do? We do not have any original. So we follow this trend. This is 360. We're not actually going to follow these dots, and neither the dots nor the line are 100% accurate, but they are close to what we can expect. For example, look at this and see the highest temperature is 32, right?
Yes.
So how would we know that what happens when the temperature is 33 or 35? So we can see this 35 and just use our expected line and see how much sales would we expect.
So following the trend,
Yes.
and continue it.
Now
Okay.
I'm actually going outside it, so I would call it extrapolation. And with this 15, I would call it interpolation because this is between the data.
So basically, for ones that we don't know or haven't been given a clear data, we follow the line for those ones.
Yes. For example, I'm the manager and I'm looking at the weather forecast. And I know that tomorrow would be 25. So I can expect this much sales, $540. I can expect this much sale. Now, what should I do? If I know tomorrow is going to be 25, I'm expecting this much sales, and that was for ice cream. I should have that much raw material present at shop. I should have those much uh, disposable cups ready. Like for example, against 100, let's say against 100 we are having 100 cups, and against 500 we are having 500 cups. So if on a certain day the temperature is below zero, I would definitely not order extra raw materials because edibles they do expire.
What about for the data that is above the line?
No
So
issues. No issues. We can this is just page is still 700.
no.
We,
I mean above the line, as in like the blue dots that are above the line, like that one.
when we draw the line of best fit, now this is like above the line and this is below the line. We just need to take care of the average data. The line should pass through close to most of the points.
So for the
Once the line is drawn, ignore every blue dot.
ones that are below, even if we have more, it doesn't matter because
Yeah,
there's going to be like it's needed for the customers.
yeah.
But if we have below, won't that be like an issue because we won't
No,
have enough for the customers?
no. See this. For example, let me come over here. At temperature 21, that this is 401. So at temperature 21, that is 401. This point. Okay. Do you expect that at some other day when the temperature is 21, this would be same or different?
It might be same.
Might be same, might not be same. Like it may depend that today is Sunday, more families are going out. May depend that 21 degrees Celsius is on Monday and everyone has a busy day.
There's
So this
different
is
factors that contribute to it, but we can still
yes,
rely on it.
Yes, this is one of the factor actually. What we are dealing with is temperature. This is one of the factor. If you just know some shop near you, like I know one near my house, that's a butcher shop, and I can pretty much notice that today is Saturday and he has much more stock than Friday. He somehow knows that there will be people just this weekend, they're coming out to shop for the next week. They're coming out for groceries. So they'll have more stock on Saturday and Sunday compared to stock on Tuesday and Wednesday, irrespective of the temperature. So there are different factors. For us, like what could be expected of us is someone has collected this data, temperature and sales, and he's asking the math student to please interpret. Now the student, based on these two values only, would tell the answer, and he is like not responsible for any wrong actual assumptions. He would say this is what the data says. Getting it? If you or
Yes.
me would have to do it, we would consider multiple factors, and yes, our assumption would be very close to accurate. We might see that temperature, okay. We might also collect the data that what was the day. Was it Sunday? Because that's ice cream. We might also see that if a school is nearby. We might also see that if the shop is on a highway or within the community center.
However, still like the above data, like the one that's very like further than the other points,
Yes,
that
like
one.
that.
So shouldn't the shop owner like provide more supplies during
Definitely.
that
Do you,
day?
do you know one word? Contingency, plus, minus,
Yes.
limits, boundaries. He would definitely have some contingencies in his mind. For example, mishandling of material, spillage. Someone just got the ice cream, and before they delivered, he slipped. Maybe there's a power breakdown, and the material which was actually inside the mixer got wasted. So this is something what he would expect. He would expect these much sales, but he'll definitely have some backup. For example, he knows his shop. He's working there since weeks or months. So he would know that I should have a 10% extra. Or he would know that I work at a very busy place and I should have a 25% extra of what is expected.
So mathematically speaking, we have to follow the line, but realistically,
Exactly,
there's
yes.
always extra.
Very good. Yes. For IGCSE, we would follow the line 100%. For A levels, and that too in physics, this topic is not in mathematics. We actually have these points, and then we have the upper bar and the lower bar for every different point. I've deliberately made the last one larger. And then what we do is we connect the lowest with the highest, and we connect the highest with the lowest. Now now you can compare. This is not the best fit line. This is the worst fit, and this is also the worst fit. What max could you expect? What minimum could you expect? Best fit is the center. So in reality, yes, he would be considering these two lines as well, max and minimum as well. Best fit is the middle one.
Okay. So it's just always extra, but for IGCSE, we follow the line.
Yes, in reality, the data would keep on changing, but in exam, in question, the data is supposed to be correct and fixed.
Okay.
Okay, so Let's say it says locate 27 on the temperature axis, which is already done with this dotted line. So x-axis at 27, it goes vertically upwards and then towards left-hand side. And we read this graph carefully. One small box, in this case, is representing 20 units because I'm looking at that 100 and below that are five small boxes. So 100 by 5, one of the box is giving me 20. Second says draw a clear line vertical. Now he's just giving you the working steps. You already know that. Worked example. Mr. Leatherfoot claims that a person's height in centimeter can give a very good idea of the length of their foot. And now, while I read this, I should not think, but I'm actually thinking, is that true? I'm having my height in my mind and I'm looking at my foot. This is what Mr. Leatherfoot claims that a person's height in centimeter can give a very good idea of length of their foot. Maybe, yes, more heighted person may have a big foot. So to investigate, sorry, did you ask something?
No, no, no.
Okay. To investigate this claim, Mr. Leatherfoot collects the height and foot length of 10 people and record the results in the table below. So foot length given, height given. Draw a scatter diagram with the height on horizontal axis because his claim was that height would give you the length of foot. So this is x-axis and foot length on y-axis. So all these points drawn in blue. Okay. Do you know before we continue what this is?
It's like a skip to a
Yeah,
higher avenue.
that's a skip jag line. Very good. If I would have drawn, like mentioned every point, my graph would just look like this. All this area is blank and the other points are being used. Okay. So question already says that draw this on x-axis, considered points plotted. Let's read one of the point. Height is 156.2 and foot length is 28.2. So 156, 140, 150, 156 and 28.2, one of these points. Second says state the type of correlation. Okay. Once done, just look at the points, ignore the red line. What do you notice? Correlation,
Positive.
positive. So correlation is positive, yes. Draw the line of best fit. See the red line that is actually close to every of these points. I'm considering this online, online, online. That's very close. On the line, on the line. Now see, these two are somewhat roughly the same distance as these two. We like don't have to be 100% accurate that 5 points should be above the line and five should be below the line. We may have 4, 5. We may have 3, 5. So we'll do few questions and you'll get that practice. Okay. So state what type of correlation the diagram has. Positive line of best fit drawn. B part. Estimate the foot length of a person with height 164. So this is 164 and we go there and read this point. So that's 26. Estimate the height of the person with foot length 17. So 15, 16, 17. Now this is 17 and we go there and read the height. So that's going to be 132 to 132 is going to be his height. Comment on the likely accuracy of your estimates in D and E. So in D and E, what do you think? Are they these accurate?
They're not 100%, but they're likely.
Yes. Let's see what wordings are they using. Most points are reasonably close to the line, so the close relation is fairly strong. You see, if if these 2 points were here and these 2 points were here, our likeliness would increase even more.
But because they're not, it's fairly strong.
Yes. This means that the line of best fit will allow a good level of accuracy when estimates are made. Now, obviously, suppose we are doing this experiment in our school and we know a person's height and we can say your foot length is this much, and you would say your claim is wrong, my foot is 2 centimeters more, but that's close, right?
Yes.
According to this graph. And also, in some cases, it would depend, not in this chapter, but in some cases, as he says that he recorded for 10 people, we can just disagree with this and say that the sample size is too small. At least do it for 50 people. For example, if you test an IQ level in your city and you ask 7 people and then give a statement based on that test that this city has an IQ of this much, that would be actually unfair. You're looking at a city of 1 million and checking only for 7 people.
The results are not reliable.
Yes. Okay. I was going to just ignore this text, but it says golden rule. Before you try to draw and interpret some scatter diagrams for yourself, you should be aware of an important rule: never use a diagram to make predictions outside the range of collected data. For
Unless
example,
they follow the trend and continue the line.
like we would, if you look at these red lines, he's actually not going out of this data. See, he may have done this. What's wrong in that? He may have done this. So he says just stay within the limit, don't assume. Whatever data is given, we are just strictly solving that.
So the limit is 200.
Yeah, if the examiner would ask you what is it when it is 200, definitely we would extrapolate. This is something where the examiner is pushing the limit. But what are our boundaries as student? We would stay within the limits
Okay.
for drawing the graph. In real life, we do extrapolate. One more thing, same ice cream example. We had the maximum value for 30U. Suppose we continue using that graph. Let's say on temperature 32, the sales are 400. What do you expect on temperature 64?
It's going to be 800.
800. Now, what do you think about my next statement? When the temperature is 64, maybe on that day, due to the heat stroke, no one is getting out of their houses. Even schools are closed.
It's possible.
Yeah. So this is what the golden rule says, that we would strictly stay within the data. Examiner may say, just like he did in this F part, we can always say the data is unreliable. We can always say the sample size is small. But whatever they are asking us to do, we are looking at the points we need to score. So we
So
are not
just
going
in
up.
case we're completely off.
Yes.
Okay.
Okay. For example, in the foot length, the data does not include any height above 183.4. The trend may not continue or may change shape for greater heights. Now, the person who's actually collected this data may also give this point that this particular graph is from this height to that height. So you should not try to predict the foot length of a person, say in 195, without collecting more data. The process of extending the line best fit beyond the collection is called extrapolation. So this also summarizes that extrapolation is not very reliable thing. Just as the case in ice cream. Temperature increased, we may expect that it's very, very hot outside and no one is getting out. Prediction when the correlation is weak. Obviously, when it is weak, we would not predict anything. stating answers in context. It is good to relate all conclusions back to the original problem. Now, the words, your vocabulary is very good. You used the word fairly, which I would also use the next time. So I would have used weak, but fairly is a very good word. So you said that the data is fairly reliable because maximum points are close to the line. So we give the answers and we choose our words depending on the same given information. We're not giving anything personal. We are strictly using the data to explain. Don't just say strong positive. Instead, you might say it is possible to make a good prediction of the height from the foot length. Good estimates of ice cream sales can be made from this data, and so
Or
on.
we refer back to the original thing.
Yes. Okay. The first exercise, and probably this is the last exercise as well. This out of this topic, with reference to the exam, what is required of us is read the question, plot the points. First thing, plot the points. Second thing, draw the line. Third thing, interpretations. He would say, what do you expect on 60? So x-axis 60 and we will read on y-axis. Nothing more than that. So what is the correlation between each of the following structure diagrams? In each case, you should comment on the strength of correlation. First one, positive or negative?
Positive.
Positive. Strong or weak?
Strong.
Okay, strong, positive. Second one,
Weak. Positive.
we had options positive, negative, and no correlation.
Then no correlation.
Yeah, so no correlation. And C part,
Negative. Strong.
negative, strong. D part,
Yeah, negative, strong still.
negative, strong. Now I'm comparing C and D, and I want to like reconsider my answer based on this D. Maybe I'll say negative and fairly strong.
So then should A also change?
In this case, yes, fairly strong. Like if I just draw the scale, this is no correlation. This is positive and this is strong positive. So when it is on positive side and this is a weak positive, so this might be fairly positive. What do you say?
Yes.
Okay, questions. The width and length of the leaves, both measured in centimeters on a particular tree, are recorded in the table below. Hmm. Width and length given of leaves. Draw the scatter diagram for this data with the length of leaves shown on vertical axis. The length of leaves, so this is y, this is x. Comment on the strength of correlation, draw a line of best fit, estimate the length of leaf. This needs to be actually practiced on graph page. And for now, let me use this. Or just a second, just a second. Maybe I have a graph. Let's download one. Okay. So we now have a graph paper. We use a different color. Now, before drawing any lines or writing anything, I'm just looking at the minimum and maximum value. So next 14 is the minimum value, 78
Maximum.
maximum value. So like just to have a rough idea in my mind that I'm starting with 14 and ending at 78. For y-axis 22, 22 I guess is the smallest value, and 201, 201 is the highest value, from 22 to 201. Now I roughly know that even if I don't go for that jack line, I know I have to fit in somehow 80 on x-axis and 200 or 210 on y-axis. So these are giving me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'm using these 16 to represent 80. Two boxes, 10 unit. So this is my 0. This is 10, 20, 30, 40, 60, 10, 20, 30, 40, 50, 60, 70, 80. And on y-axis we had till 200. So probably, if I remember it correct, these were 25 boxes in the vertical axis. So 10, 10, I'm going to take this 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40, 50, 150, 60, 70, 80, 90, and 200. In reality, this would be much neat than what I'm doing. We'll be using a scale and drawing these straight lines as well on both axes. We are going to label the axis. X-axis were width in centimeters and same y-axis length in centimeter. Now first point is 1422. X14, Y22. 10, 11, 12, 13, 14, and this is 20, and this is 22. 14, 22. I'll try to be as accurate as I can with the points. Then 25, 63. 25, 60, 1, 2, 3. 67, 170. This is 60, 5, 6, 7. And just so I do not miss the track, I'm writing this line with me. So this is 50, 60, 70. That would be much more easier on paper. 56, 141. 56. So this is 50, this is 55, and one more 56, and 141. 10, 20, 30, 40, and one is exactly between these two boxes. 26, 76, 25, 16, and 70. 1, 2, 3, 4, 5, 6. 78, 201. This is 70, 75, 75, 200, 76, 77, 78, and 201. Are these dots visible? 33, 93. So 1
Yes,
to 3.
dots are visible.
And when I reach this 100, this is 90, 1, 2, 3, 33, 93, 35, 91. X 35, that's 91, 14, 24, X 14, Y 24, 36, 91, 36, and 91, 13, 20. Oh, we had the smallest value, 13. Sorry, 13, 23. So then this is
Where's the
13.
cases we did it with 10? So
Yeah,
we are doing
we actually used 0 as well. So no issues. 36, 67, 35, 6, and this is 60, 1, 2, 3, 4, 5, 6, 7, 25, 51, 25, 51, 62, 151, 62, 100, 150, 1 and 62. Is this 25 and 79? It's 25, 60, 70, 80, 79. Okay. Okay. So these are our points. Then it says draw, done, comment on the strength of correlation. What do you say?
I would say it's fairly strong.
And positive.
Yeah, positive, fairly strong.
Okay. Next point says draw the line of best fit for this data. Now, uh, I would make attempts, or you can see this cursor moving.
Yes.
I'm going to try to draw a line through this, and it should be a bit higher. Um, yeah. So that's line of best fit. And I tried it to stop my hand till the last point. If I would erase it, it would erase the complete line. So I'm keeping it. Estimate the length of a leaf that has a width of 20. So 20. So I get 42. If the width is 20, length is 42 centimeters. Clear?
Yes.
Okay, let's have a look at the entire exercise. All of these are going to be of same nature.
Oh,
For
that's it.
yeah, yeah. This is the complete chapter. Get